Hi guys. In this session, I'll be giving a tutorial on how to load the head rig using the newest mode pipeline and how to merge it with the body rig. First of all, you must make sure that the Metahuman for Maya plugin is enabled in your plugin settings. If you set the Metahumans folder inside the Tuna rig folder in your local documents directory as the assembler path, you should be able to see the Ada character. We will load only the head of this Ada character as we'll be using her head rig as a template. Once you've loaded the head, please open the DNA editor. A button to open the character assembler has also been added. Let me remind you again, from the newest DNA version, that is MH.6 and above, you must not use DNA Viewer anymore. When you open the DNA this way, you can now check the DNA version info directly in the DNA editor. Once again, for DNA versions MH.6 and above, do not use DNA Viewer under any circumstances. Instead, we use the Character Assembler. Now, we will transfer to your own character head. Please bring in the pre-made Metahuman head LOD0 mesh. I will bring in the head mesh I created earlier as a reference. Here, I will cleanly copy only the mesh and then delete the reference. I have brought in all the head LOD0 mesh and additional meshes. These meshes were created using the meshWarp's Metahuman automated function, so please make sure to study the related tutorials beforehand. Now, I will separately copy the head LOD0 mesh and use it as the target mesh. You need to save the DNA output path. I will overwrite the existing Ada head DNA. Now, click on Run Transfer. Once the settings are complete, even with just the head LOD0 mesh, all joint positions will be set up and additional meshes will be generated automatically. However, we are not going to use those auto-generated meshes anyway. We need to replace them with the ones we created earlier. Also, not only do we need these meshes, but it's also good to bring in all the LOD meshes as well. I'll bring in all the head LOD meshes that were previously created with meshWarp. After deleting the reference, the shader gets broken, so, for now, I'll apply Lambert 1. Let's first swap the additional meshes of the head mesh. This function automatically replaces the meshes by finding ones in the DNA that have matching vertices with the selected meshes. You can immediately see that all the pre-made additional meshes have been replaced. Now, for all the LODs as well, select all the pre-made meshes and replace them. The reason we need to replace them is that the LOD meshes automatically generated by the transfer and the LOD meshes created beforehand using meshWarp are slightly different. The LOD meshes created with meshWarp take the body shape into full consideration, so they are much more accurate and do not show seam lines. Select all the pre-made LOD meshes and click the Swap Selected Mesh button. And you will see that everything has been cleanly replaced. Now, let's look at the joints. Most likely, the eye joint will be slightly offset from the eyeball mesh. Of course, it's already somewhat aligned, but there is a way to make it more accurate. Just run Auto Match Eye Joints. Now the positions of both eyes have become much more precise. Now, you can manually adjust any other joint positions as needed. It's usually recommended to adjust the teeth joint so that it is centered properly in the mesh. You can make these adjustments while the mesh is still skinned and moving. Or, if you're only adjusting joints, you can turn on the Skin Off function and make the changes. Now, if everything is done, please click Save Transfer Setting. Then we will save it as a DNA. Just proceed like this using the existing pipeline. After that, for editing the behavior logic of the DNA, follow the previous tutorial as it is. Now, I will go to the folder where Ada is located and overwrite the head DNA with the DNA file I just created. I will delete the existing head DNA and rename the cartoon DNA I created to head. Now let's open the character assembler and load only the head. As you can see, it looks wrinkled and strange, right? This is because the head mesh's normal is still using the original Metahuman's normal. If you try closing the eyes, you'll see the area around the eyes looks dark. This means the normals are locked. If you do unlock normals in Mesh Display, the normals will be completely unlocked, but they'll look sharp and faceted. Even if you use the Soften Edge function, in this state, you will still end up seeing visible seams with the body mesh. This issue doesn't only apply to the head LOD0 mesh, it affects all LOD meshes. In this case, you need to bring in all the LOD meshes that were previously created with meshWarp as references. I will copy only the head LOD meshes and delete the reference again. Since the shader nodes are broken, I'll temporarily open the hypershader and apply Lambert 1. Now open TunaUtils and go to the Change Shape section. We will now replace each of the pre-made LOD meshes one by one. Once replaced like this, the previous normal issues will be resolved, and the seam problem when merging with the body mesh later will also be fixed. Change Shape automatically backs up meshes that have skin data. The tool does this just in case, but for us, it's not needed at the moment. You can see that the original mesh has all normals locked, displayed in yellow. However, the mesh we just replaced doesn't have locked normals, and all areas except the border lines are shown in green, meaning the normals are calculated smoothly. Let me say it again. These pre-made head LOD meshes can be created directly through meshWarp, so please keep that in mind. Now turn on all the LOD layers. If it's too much hassle to turn them on one by one, you can go into Metahuman Utils and TunaUtils and clear the head LOD layers. Now, based on the existing LOD meshes, we will replace the shapes of all the head LOD meshes. I will delete the backup meshes. Now, even when the eyes are closed, the normals appear naturally. We will now save this scene as it is. Because we need to bring this scene into the body rig, now let's load the scene that contains the body rig. Let's open Metahuman Set. In the previous legacy mode, you would import the head rig directly into the current scene and then run Connect Head Joints. However, in the newest mode, you use the Import Head Rig button to load the entire head rig scene and automatically merge it with the body rig. That's because only then can you manage the root joint as a single one. The idea of the new Characator Assembler is not to separate the root joints of the head and body, so we had to design accordingly. Click the Import Head Rig button and select the head rig file that we saved earlier. When you load the head rig like this, it is automatically merged with the body rig. Both the body rig and head rig are now set under a single root joint and are no longer separated. The head rig is also working properly as before. If you try moving the head joint, you can see that it follows along correctly. It's not connected through a separate node. It's actually merged in the hierarchy. Oh, the head skin data seems to have a slight gap compared to the body skin. You can also see that this gap appears when lifting the clavicle. In this case, you need to go to the subtools and use the Auto Skin Load function. Check all the XML files related to the head LOD meshes, and if the body mesh hasn't been skinned yet, make sure to check that too. For now, since I already skinned the body previously using this, I'll only apply it to the head. I'll turn on all the head LOD meshes. When using this function for head meshes, do not unbind the skin from the existing head meshes. Just use them as they are. All right, now all the skinning is complete. As you can see, there's no longer any gap between the body and the head. Since we previously replaced the LOD meshes correctly, you can also see that the borderline vertex normals between the two meshes match precisely. Now we need to save the head-related joints that are matched to the body back into the DNA. As you probably know, the first joint for the head saved in the DNA starts from spine 4. Since the body joint in the newest mode has only one root joint, you can load the DNA directly into the DNA editor without attaching a separate namespace. If you go to the Geometry tab in the DNA now, you can see that the first joint is spine 4, right? But currently, spine 4 is parented to spine 3, so its transform value is not in world coordinates. It's currently in relative coordinates. If you save the DNA in this state, it will cause serious problems. You must never save it with relative coordinates. You have to temporarily unparent spine 4 completely from the hierarchy before saving it. Let me say it again. You absolutely must separate it before resaving to DNA. I'll now set the path for the DNA file to be saved. Here, it's asking whether to save the current geometry information as well. For now, we'll just save everything. Now that it's been saved correctly, let's move spine 4 back to its original place. We're almost done. Now let's apply the shader. To apply the shader, the corresponding Metahuman shader must exist in the current scene. The simplest way to make that happen is to load the template mesh from meshWarp. I'll temporarily load Ada's template, but you can choose any template you prefer. As long as the shader is applied to it, any template will do. Even when I press the 6 key to view the viewport, it still looks like the shader hasn't been applied. If you check the file path editor, you'll see that some of the paths are broken, right? In that case, click the double arrow icon in meshWarp. Then the workspace will be set to the default project in the Maya Documents folder, and the broken shaders and textures will automatically reconnect. After checking the file path editor again, it looks like all the shader textures are properly connected now. But strangely, the shader still doesn't seem to appear in the viewport. In that case, open the Maya Preferences window and go to the Display tab. You'll probably see that the viewport setting is set to OpenGL. Change that to Direct11 and restart Maya. I'll save the current scene and restart Maya now. All right, now that the template mesh's shader has been loaded properly, let's temporarily hide it. Then open the Metahuman set and apply the material. Since the template is no longer needed, you can delete it. If you want to delete unused nodes and clean up the scene automatically, use the Scene Cleanup function in TunaUtils. If the shader is not applied to the body, just load a template related to the body and reapply the shader. Now it looks like almost everything is working well. Next, I'm going to overwrite the body DNA and head DNA files I saved earlier into Ada's Assembler DNA folder. Let's copy and paste the body DNA. As for the head DNA, I already saved it to that location earlier, so it has been overwritten. I'll delete the existing DNA and use this new one instead. Now let's open a new scene and load both the body and the head using the Characator Assembler. As you can see, everything has been freshly loaded. When you bring in both the body and head using the assembler, even if the eyes are closed, the vertex normals will still appear smooth. However, you can still see the seam line between the body and the head here. Even though the vertex normals of the two meshes match, the normals here are locked based on the original Ada normals, which is why it looks off. As I've mentioned before, whenever you bring in new mesh data through the assembler, you absolutely need to replace it with the correct LOD meshes we previously prepared. Let's bring in the original LOD meshes again as references. This time, We need to replace both the body and the head, so I'll copy both and then remove the references. Now, should we use the change shape function again and manually go through each mesh one by one to replace them like we did before? But there are too many to replace, right? It's easy to make mistakes in the middle of the process. To reduce that kind of effort, we've actually added a new feature in TunaUtils. If you go to Metahuman Utils, you'll find a function called Auto-Match Selected Mesh to All Scene Meshes. This feature finds all meshes in the scene that have the same vertex structure as the selected mesh and automatically replaces their shape with that of the selected one. So if I select all the pre-prepared body meshes and press that button, all the body meshes in the scene that share the same vertex structure will automatically have their shape changed to the selected ones. I'm going to select all the head LOD meshes and all the body LOD meshes at once and apply the function. It's been replaced, and a message appears saying the source mesh can now be deleted. Just like when we use the change shape function, backup meshes have been created. Let's check to see if the replacement was successful. There are no longer any visible seam lines. Everything has been perfectly replaced and done cleanly without a single mistake. Since I want to check all the LUDs, I'll delete all the layers for now. Now you can delete the source meshes we brought in earlier. Let's take a look to confirm if the other LOD meshes were applied correctly. Yes, all other LODs have been correctly applied. The auto-match selected mesh to all scene meshes feature is very powerful, so make sure to use it well. It replaces all meshes in the scene that share the same vertex structure. Now you can either continue working with this newly imported assembler data or stick with the scene you are working on that uses the original rig template. The cleanest and most accurate data comes from importing DNA directly via the assembler. But if you're making rig modifications, using the rig template scene we provide, just as you've done before, will likely be more efficient. Either way, the export process is the same, so it doesn't matter which one you use. In the next session, I'll show you how to export the newest base setup and bring it properly into the engine. Thank you for watching.